The last type of charts we are reviewing from the perspective of R is box plot. So far we have done 3D plotting and histogram, and there are many others, but since it is introduction to R, and I just want you have a glimpse of what visualization looks like in R, we are doing this review type of things. But box plot is popular, quite popular type of charts in statistics. As you can see here, descriptive statistics, that it shows spread and skewness groups of numerical data through the quartiles. Quartiles is that 25%. For example, here, what you see here, this shows, let me write it for you. It shows that, for example, for this one, that we are going to do this very soon, this is the minimum. So it is the minimum amount of this category of data. This is 25%, the first quartile. It means that 25% of the data are below this value and 75% are above this value. Here we have median 50% below, 50% above. Here we have 75%, and here we have the top one, and all other things over there. I don't know how many software packages have you seen so far that plot for you box plots. I don't know, maybe in one of your general math classes you have had um, in high school or in university. You are acquainted, you are familiar with some softwares that do this type of plotting, that I just tell you what's the point of that, because with a glance you can quickly figure out and compare median, 75%, top, and everything. That's the reason this type of charts are popular in any field that they use descriptive the descriptive statistics. Okay, so let's do it with R together. And since now you already know about the way you structure functions, visualization functions in R, so we skip many of the points because they are similar to histogram. And again, as you can see here, it says a box plot depicts information like the minimum, maximum data points, the median value, first and third quartile, and interquartile range. The interquartile range, it is here, so you can see the, for example, the range between the fourth quartile and the third, the range between the minimum and first and second, and here it is third. Okay, to do this, it's very simple. So just follow me and do these things here. It says download this CSV data box plot at this address, and we are going to run this with some explanation over there that I'm sure you are going to get completely. Let's go. Okay, let's read our data as that one. Read the CSV file that choose. So you please also follow me while I'm doing these things, and when you are behind, just stop the video, and if you are ahead of me, go and continue on your own until I catch up with you. Okay, now I have these, and I'm going to the data that I have downloaded to. Okay, here it is the box plot. Okay, now we have data 1 here. Let's view it. It is the data that you see here. What is the data here? First, you have the name, and after that, they are the name of cars, for example. A is a car, B is a car, C is a car. MPG, miles per gallon. For example, it says that car A has MPG 38, car B has MPG 24, and also we have the cylinder of the cars. For example, car E with MPG of 15, it is 8 cylinder. Okay, so now we are gonna run our model on this data to see what we have. Okay, we want to do box plot. I get box plot here, and as you remember, as I told you, always start very simple. When we start simple, so I'm gonna put the data I have. So it is that one, but I want the columns, not the name of the cars. I just want the MPG and cylinder. So I go all the rows and 2, 2, 3. We have talked about all this way of coding before. So as you can see, I'm telling it box plot, data 1, 2, 3. So what we expect to happen, we expect something that I just showed you in the PowerPoint that you can go and check. There were several categories, and over there you could find the minimum, first quartile, median, third quartile, and the maximum amount. But here, since we have two columns, we have you will see we will have only two box plots. So I run this, and it is the result as we expected it. The first column was MPG and the second column was cylinder. It says that MPG, the minimum amount, is here. It is 25%. It means 25% of the cars MPG is less than about 19. Here is median. As you see, it is about 24. And like that, and about the cylinder, you see, it has, since it is only two values, the minimum is 3, the maximum is 8. That way simple, you can handle that. What about the other things that you can add? You have learned about them. So I'm gonna, for example, add color. Not all of the things that we discussed are working here. Let's put it red and color red, and I run this. And it is that one. But another point, and this is the last point we are gonna discuss practically regarding visualization. My friends, you may ask that what if you want to have the box plot based on one of these values? For example, what if you want to see MPGs for 3-cylinder separately, MPGs for 8-cylinder separately, MPGs for 6-cylinder separately? Here, you consider MPG independently, makes sense. You consider cylinder independently, that quite makes sense. But again, I'm telling you, what if you want to categorize this data, these MPGs, based on cylinders? Let's see how we are going to do that. Box plot. It is in coding, and it is the first time I'm telling you this. It is not something that you are supposed to know, my friend. Okay, so please stay confident that it is something that it is about coding, and we will learn about these techniques more in future. But here you define that, you say that box plot MPG tilde on cylinder. And after that, you give the data. So R goes and check that data for you for this type of stuff that we have. So 2, 2, 3. So let's check it what's happening here. I'm saying that to R, please box plot for me according this information I'm giving you. The data is here that we also have a box plot of that, but here it says that we want our box plot in this way. The y-axis is MPG and the x-axis is cylinder. Always tilde is used to model in this way. For example, when you want to say that something is output, something is input, you put the inputs on the right of tilde and you put the output on the left. When you want to put something on the y-axis and x on the other side, x and I confused what I said. Okay, when you want to put something on y-axis and the other thing on the x-axis, you are gonna use this. And it is very similar still to the fact that they are input-output. For example, here, when we say f x equal to x2 and it is y, so in fact y is some sort of output and x is some sort of input. That's the reason you see MPG on the left and cylinder on the right. And now here, okay. So now it was the things that I told are box plot. So again, I'm telling you, it is something that has the knowledge of R coding behind that I just gave you a glimpse of. So stay confident. And you were not supposed to know this, but always output on the left, input on the right. Now see what happens when I run this. So you see, it put MPGs on the left and on the left, I mean y-axis, and it puts the cylinder on the x-axis. Now we are seeing MPG box plot for 3-cylinder cars here, and we see MPGs for 8-cylinder cars here. So as you can see, the maximum MPG of 8-cylinder is smaller than the minimum of MPG for 3-cylinder cars, and many other analyses that you can do, and you can see how much box plot could be helpful. And when you are practicing these things on your own, please feel free to check the manual that I told you that is on our website. So you can add some other features over there and see the results. But totally executing our functions, even for visualization functions that it has, is straightforward. As I told you, there are many other categories of visualization techniques that you can find in R. For example, heat map that color something according to the values, color a matrix according to the value, or map. For example, you have such a thing because it's a programming language and you can do all the things that I'm telling you just to know how much strong and unique is visualization in R. Thank you so much.